Hello, this is another video in the playlist for Linux beginners. Now let's have a look at signals, the background and the foreground command, and nohup or no hangup. In the second video of this playlist, we saw that when you run a program or script, a child process will be created in which the command is executed, and when it's done the child will exit and you can continue in the original bash shell and run any other command. But sometimes you run a command that doesn't exit after a second or so. So for example, if you run a backup or start some analytics or any other program that takes time to finish, if it finishes at all, you will not be able to continue in your bash. And what's more, you won't be able to log off either because your shell is waiting for the command to finish. Now before we look at that, let's get the following out of the way. The kill command, which is what we're going to be using, does not always kill processes. Far from it. The kill command sends a signal to a process, and sometimes this indeed means that the process will be killed, like with the default signal 15, which politely asks the process to terminate. The signal is called sigterm, or with the hard kill, which is signal 9, or sigkill. This is the unfriendly kill, which you shouldn't use randomly, but only when the sigterm doesn't give you the desired result, because it will brutally kill the process. But these are only two examples of signals that can be sent to a process. There are many more signals. Let's look at the relevant signals for this exercise. So we list the signals with kill-L. Now don't worry, we're not going to discuss all of these signals, but only the relevant ones. Let's start with sighup or hangup, which is the signal that a child process will receive when the parent exits. So if you exit your shell, it will send a hangup signal to all of its children. So in fact, when you close the shell and you have a child, then the child will receive signal 1 or sighup. And also nowadays, the hup signal is used to kind of prompt the process to reload its configuration by reading its config file. So in fact, it is then used to reinitialize a daemon. So you don't have to restart it, you simply send it the hup signal. You could compare this to a plane coming in, touching ground and take off again without really stopping. Then there's sigint, which is signal 2, which will interrupt the process. So if we run a program that takes ages to finish, we could interrupt it by simply typing Ctrl+C. And finally, for this discussion, we need two more, signal 19 and signal 18. 19, or sigstop, will pause the process. So you don't kill it, but stop it temporarily. So instead of using Ctrl+C, you can type Ctrl+Z, which will send signal 19, and then if you want to continue in the background, you should run BG or background. And if you want to get it back to the foreground again, you simply send signal 18 or run FG. Now I apologize for all of this theory. Let's go for a practical example. I have a very small script that goes to sleep for 5 seconds, then refreshes and goes back to sleep again. Very interesting. Now I've started it as if it were a normal program, but since this is an endless loop, I can't log out because the child is active and the parent is waiting for the child to finish. This is never going to happen. Now I can send the interrupt signal with Ctrl+C, but that will stop the program permanently, like this. So it's dead. Now I start it again, and now I'm using Ctrl+Z, or in other words, I will send signal 19. Now it says it has stopped, and when I run the jobs command, it shows that the job has stopped. Now using the BG command or background, we'll start the job in the background and it will continue. The job is running again. If I then run FG, which means foreground, it will bring the job back to the foreground, and I can stop it again with Ctrl+Z. And again, I start it in the background and now I can log out. This will send the sighup signal to the job, so kill-1. Now I log in again and search for the job. Obviously, I do not have any jobs. But my script is still running. Let's see. And to our great pleasure, we see that the job is still running, but now it has a different parent. So in fact, this is like an orphanage. When the parent dies, the child will get a new parent in the form of PID1, which is actually system D. There's one thing that's missing though. We do not see any output anymore. The child is running, but it has no location to output its data to. Now let's kill it permanently. Of course, we have to be root in order to be able to do that because it's no longer a user process. Now let's start the script once more, but now we're going to use the nohup command or no hangup. This means that the shell will not send a hangup signal to the child when the parent leaves the system. So this child will keep on running. It will still get a new parent, but it will keep on running. So to run it in the background at starting time, we can simply add an ampersand to the command. So we run nohup, the script name, and then the ampersand. Now it says the output will be sent to a default file called nohup.out. So It won't output it to the screen anymore. Now let's follow this with the tail command. And as we see, it happily runs in the background and writes its output to this file. So once more we log off and go back in and to check the script and its output. We see 1 is the parent and we check the file, and indeed the output of our script is not lost. And we're very happy and we're done.